Chapter 11, Areas of Polygons. Today we're going to cover section 11-4, day 2. Find the area of each polygon. A square with a radius of 2 square roots of 2. So the first thing I'd like to do is draw myself a picture. I know that if the radius is 2 square roots of 2, I can find the apothem. I know this is a 45, 45, 90 triangle. So if I go from this radius to the apothem, I would just divide by the square root of 2, which would give me 2, which means this side down here is 2, which means that an entire side is going to be 4. So if I use the formula for area equals 1/2 apothem times perimeter, I would get 1/2 times the apothem, which was 2, because it's sort of this height right here in the middle, times the perimeter. If one side is 4, the entire perimeter is 4 times that, which is 16. And then if I just multiply across, half of 2 is 1. 1 times 16 equals 16. Or I could even, if I wanted to, do, since it doesn't tell me how I have to, the area of a square is a side squared, which is just 4 squared, which is also 16. Number 2, an equilateral triangle with an apothem of 2 square roots of 3. So if I think of an equilateral triangle, I know the apothem is 2 square roots of 3, and I know if my formula is that the area equals 1/2 the apothem times the perimeter, the only thing I really need to figure out is what's the perimeter. So in my 30, 60, 90 triangle over here, I'm going to look for this piece on the bottom. So if I go from 2 square roots of 3 to that piece, it gets bigger by the square root of 3. So it's going to be 2 square roots of 3 times the square root of 3. Well, I know the square root of 3 times the square root of 3 is 3. 3 times 2 is 6. So if that much is 6, an entire side of the triangle must be 12. So if I come to my formula then, I have area equals 1/2. Apothem was 2 square roots of 3. And the perimeter, if one side is 12, all 3 sides is 36. And now I'm going to multiply. Half of 2 is 1. 1 times 36 is 36. And then I still have the square root of 3. Number 3. A regular hexagon with perimeter 24 square roots of 3. I'm thinking again of my formula, area equals 1/2 apothem times perimeter, and they're already giving me what the perimeter is. So if I can figure out what the apothem is, I'll be able to go to my formula. So drawing up myself a picture, so a regular hexagon. The perimeter is 24 square roots of 3. I know there's 6 sides, so if I take the perimeter and divide by 6, I know that each single side is going to be 4 square roots of 3. So if I draw in my triangle in here, I know that if an entire side is 4 square roots of 3, then the part of the triangle that I'm going to use is just going to be 2 square roots of 3. Trying to figure out what the angles are in here. Well, I really want to get this angle right in here inside this triangle. Well, I know if I drew one of the larger triangles, sort of like this one right here, I could draw 6 of them inside of this hexagon. So a complete circle is 360, divided by 6 gives me that this large angle at the top would have to be 60. So the triangle that I'm working with means that that angle up there is going to be a 30-degree angle. So if I'm going from this 2 square roots of 3 down here at the bottom, and I'm looking for the apothem, I just need to multiply by the square root of 3. And 2 square roots of 3 times the square root of 3 gives me 2 times a 3, which is really just a 6. So I know that my apothem is going to be a 6. Now when I go to my formula, I get 1/2 times the apothem, which is a 6, times the perimeter, which they told me is 24 square roots of 3. Well, half of 6 is 3. 3 times 24 is going to be 72, and then I still have the square root of 3. The regular polygon is inscribed in a circle with a radius of 1. Find the apothem, the perimeter, and the area of the polygon. Use square root of 2 equals 1.414, and the square root of 3 equals 1.732. So, looking for the things we need to find. They tell me the radius is 1. I'm going to draw that in right away. Radius is 1. And they want me to find the apothem. They want me to find the perimeter. And they want me to find the area. And I know that to find the area, I really need the apothem and the perimeter anyways. So let's start to fill in. They give me that this radius is 1. I know if it's a square, I get a 45, 45, 90 triangle. And if that side is 1, and I come to either of these other two sides, I just need to divide by the square root of 2. So I think 1 divided by the square root of 2. If I rationalize that, equals the square root of 2 over 2. So my apothem is the square root of 2 over 2. And half of a side down here is the square root of 2 over a2. And if half of a side is the square root of 2 over 2, then it must mean that an entire side is just double that, which would be the square root of 2. So looking over here to the left then, my apothem I figured out was the square root of 2 over 2. If one side was the square root of 2, all four sides would be 4 square roots of 2. And my area, I know, is going to equal 1/2 times the apothem, square root of 2 over 2, times the perimeter, which is 4 square roots of 2. And if I look, I can do some reducing. 2 goes into 4 twice. The 2's reduce. And the only thing that's left is the square root of 2 times the square root of 2 is 2. Now, going back to the original problem, they wanted me to get decimal answers for these. So the apothem, instead of writing the square root of 2 over 2, I'm going to go to a decimal and figure out what the decimal answer is that they want. So it says for square root of 2, use 1.414. 1.414 divided by 2 is going to be 0.707. Well, there's another square root for the perimeter, so let's change that one into a decimal. So that one's 4 times the square root of 2. And again, for the square root of 2, I'm using 1.414, multiplying that by 4. And for the perimeter, I'm going to get 5.656. And our area didn't have a square root in it, so we didn't have to worry about it. So our final answers are these 3 decimal values.